Okay, so in this lesson, section 4, lesson 4, we are going to be solving quadratic equations. We are going to learn 4 different ways to solve these. Today we are going to solve them by factoring, everybody's favorite, by square rooting it, and then the next couple days we will be completing the square and also quadratic formula. So generally, quadratic formula you can use to solve anything. But today we're going to factor. Not all equations can be factored, so that's why there's different methods. All right, so before we start, let's talk about what a quadratic equation is. So a quadratic equation is ax squared plus bx plus c, where a, b, and c are just numbers. So when you have a quadratic equation, your largest exponent is going to be a 2. It's going to be a degree of 2. So for example, a quadratic equation could be x squared plus 4x plus 4. This is an example of a quadratic equation. We've already seen a lot of these in the review chapter. So what we're doing today shouldn't be new because we already did it in the review chapter. So the difference between what we've been doing before is all of the questions before we were factoring only. Today we're going to solve, so we're going to take it one step further. The other method, so what we're going to do is, in order to solve, once we factor something, we're going to apply the zero factor property. And I'm just putting this here just to make you aware of it in case you see it on a standardized test. But x squared plus 4x plus 4, I'm looking for 2 numbers that will multiply to give me 4, that will also add to give me 4. Anybody know what they are? 2 and 2. Okay, so then to apply this zero factor property, what you do is you take each one of your binomials, you set them equal to 0, and then you solve. So here we would subtract 2. Notice this time it's both the same answer, and we're going to talk about this in a minute. So our solution here would be -2. So after you factor, you're going to have to set them equal to 0 to find the solutions. The other method is the square root property, and this is where you just have x squared equaling a number, or even some kind of squared term equaling something, and you square root both sides to find the answer. Now, we did this quite often, for example, in geometry when we did Pythagorean theorem, and we were trying to find c, and we had to square root the c squared. In geometry, we never dealt with the negative square roots, because we never wanted a negative side length. But in Algebra 2, when we square root something, and they're asking us to solve it, we have to take into consideration both the positive and the negative square root. Now, just a quick review of what graphing a quadratic looks like. So when you have your quadratic equation, your quadratic, the graph of it is called a parabola. So it looks like a U shape or an upside down U. Now, when we're solving our quadratic equations, the answers we're getting is the x-intercepts. So when it says to solve, what we're finding is where our graph will hit the x-axis. So keep in mind, when you solve them, you can either get one answer like we just saw, because it's sitting right on the axis. You could get another answer where there's 2, because it crosses the x-axis twice. And you can also have a graph where it never touches it, and that would be a no solution. And then we can also have our imaginary roots. So know that when we solve these, we can either get no solution, one solution, two solutions or an imaginary solution. So this is what we're going to be seeing as we solve these. And again, remember, when we solve, no matter what method we use, we are finding the solution that we come up with, the x equals, is where it hits the x-axis. So let's try some of these. Our first instructions say to solve by factoring. So on your quiz and test, they're going to have specific instructions. And I'm going to ask you to demonstrate how you would solve this, and you're either going to use factoring, square root method, completing the square, or quadratic formula. So you'll have to follow the instructions when you get your answer. Technically, we could use the quadratic formula for every single quadratic equation if you like plugging things into just a set formula. But if the instructions like this says to use factoring, that's what I want to see. So we are going to factor this. Now, I could have also solved this by square rooting it, but right now the instructions say to factor. So my first step is to set my equation equal to 0. So the first step is to move everything over to one side of the equal sign. So I'm just going to move the 1 to the left side by subtracting it. And I get x squared minus 1 equals 0. I now have a factorable equation. It is actually the difference of two squares. So I'm going to factor this into x plus 1 and x minus 1. Now, if the instruction said to factor, you would be done. You would stop here. However, the instructions say to solve. So what I need to do now is I'm going to apply that 0 product property, and I'm going to set x plus 1 equals 0 and x minus 1 equal to 0. And now I have to solve the simple addition and subtraction equations. So I will subtract 1, x equals negative 1, add 1, x equals 1. And these are my two solutions to that quadratic equation. Yes?
What about the test that you forget that you don't look?
So for number 2, notice it's already set equal to 0. So now I just need to factor this. Now, it's not the difference of two squares, and it's not a trinomial either. How can I factor that left side?
GCF.
Beautiful. So there is a GCF of x, so I'm going to divide by the GCF, and I end up with x outside the GCF, and then 3x plus 1 on the inside. Now I'm going to apply that 0 property, and I am going to set x equal to 0. All the pieces get set equal to 0. So x equals 0. And then I'm also going to set 3x plus 1 equal to 0, and I need to solve for x. So I'm going to subtract 1, divide by 3. So I have two solutions here. I have x equals 0 and x equals negative 1/3.
Can we write x equals 0, comma, negative 1/3, or else write separate?
You could do that. You could put it together. Okay, so for this one, if I were to square root both sides, I would end up getting one of the roots but not the other. So I am going to solve this using factoring. I need to make the equation equal 0, so I need to move my x to the other side. So I'm going to subtract it, and then I'm left with x squared minus x equals 0. And now I can't, it's not the difference of two squares, it's not a trinomial, but again, I can pull out a GCF of x. So I can divide it by x, and I'm left with x minus 1. And again, I'm going to set each piece equal to 0. So x equals 0. And then the x minus 1. And then I will add 1 to both sides. And x equals 1. So my two solutions here are 0 and 1. For number 4, we have a trinomial. My equation is already set equal to 0. So now I can just begin factoring the left side. What are two numbers that will multiply to give me -8, but will add to give me +2? 4 and -2. Everybody good on that? So x plus 4, x minus 2, because 4 times -2 is -8, and when I add them, I get +2. So if it said factor, we would be finished, but it did not say factor, it said solve. So now I take each one of the binomials, set them equal to 0, and solve for x. I'll subtract 4, and I get x equals -4 for my first solution. And then my second is going to be x equals 2. So I have two solutions, -4, +2. Next one, number 5. Notice I have a term in front of x squared. It's a 2. Now, if you're going to do the guess and test, you could start out and list your factors of 2 and then your factors of 15 until you find the one that works. I'm going to go ahead and do the multiply, the beginning and the end. So I'm going to multiply 2 times -15. So I'm looking for the two numbers that'll multiply to give me -30, but add to give me -1. So those factors are going to be 5 and 6, and the 6 is going to be negative. So if you're doing my trick, you take the 2x, you write it at the beginning of both, and then here, -6, +5. Remember this step now. If you were to try to FOIL this, it would not go back. So remember, you have to reduce this one, and I can reduce it by dividing them both by 2. And now at this step, I highly recommend you FOIL this thing, because if it doesn't go back to this, then you've picked the wrong numbers or you forgot to simplify. And remember, when you do the simplification of the binomial, this is the one where you throw away the GCF. So if I FOIL this, I do get the -15 for the last term and the -1 in the middle. So I'll go ahead and put these up here. So 2x plus 5 and x minus 3. So now I set each equal to 0 and solve. So for the first one, I'm going to subtract 5 and then divide by 2. You can leave these improper. However, if you were graphing this, you might want to make it a decimal or a mixed number so you could see the x-intercept. But if it's just asking you to solve, just leave it improper. And then the other solution, I'll add the 3 and x equals 3. So I have -5/2 and +3. Now for number 6, notice I have a negative number in front of my x squared. I always like to make that x squared term positive. So instead of adding the 10, I'm actually gonna add the 6x squared and subtract the 7x. You could factor it with a negative term in front. It just makes it a little more challenging. So instead, I'm gonna move everything to the other side. So my x squared term is positive. So then I get 7x equals 6x squared minus 10. Subtract the 7. And now I have my trinomial, and I'll put it first. Let me just flip the 0 to the end. So now if I do it where I multiply the beginning and the end, I'm looking for factors of negative 60. That will give me negative 7. And I'm going to try 12 and 5, and my 12 is going to be negative. So if I set it up as 6x minus 12, and then the 6x plus 5, when I reduce this one, it becomes x minus 2, and this one I can't reduce. So now at this point, I'm going to FOIL it to make sure it did go back to the original one right here, or the one that I rearranged. So when I multiply the last two, I do get negative 10. Then the outer gives me positive 5, inside gives me negative 12, and I do get negative 7. So now I'll write those underneath. And now I'll set each one of them equal to 0 so I can find my solution. So x minus 2 equals 0, and 6x plus 5 equals 0. I'll add 2, and I get x equals 2, subtract 5, 6x equals negative 5, divide, and x equals negative 5 over 6. So my two solutions are 2 and negative 5 over 6. Next, we're going to solve by using the square root method. And again, we saw this in geometry when we were trying to find a missing side of a triangle when we did Pythagorean theorem. So for this problem, I am going to rewrite it so I can show some work here. So x squared equals 17. To solve for x, I square root both sides, and that will cancel the square, leaving me with plus and minus square root 17. If that radical could be simplified, I would, but it's not a perfect square. I can't break it down, so I'm done. Yes?
You know how like there were times you could like pull out like, let's say for like 24, you could pull out a 4. Can we do that?
Yes. And we're going to see that coming up. All right, let's try the next one. Number 2. Yesterday and the day before, we learned about negative square roots. So remember, in the past, we would always say we couldn't do it. It wasn't a real number. But now we know how to work with imaginary roots. So I'm going to square root both sides. I get x equals, and if you wanted to break down the root like this, I know you guys have gotten practice now, so I'm okay with you going right to the answer, which will be plus and minus 5i, because the square root of negative 1 is I, and the square root of 25 is 5. So plus and minus 5i. So here, the square root of negative 1 is I, and the square root of 25 is 5, and then I'm just going to flip it around and put the 5 first and the I second. So again, as soon as you see you have a negative root, you know an I is coming out. And then from there, we're going to deal with the number. I'm going to rewrite it. Now, notice this time, I've got an expression that's raised to the second power. But my process is the same when I use the square root method. I am going to square root the left side, and I square root the right side. And now when I square root this, square rooting the square makes it cancel, and then what comes out is x minus 4. I need to break down my 12, so I'm going to break it into 4 times 3. And then I can square root the 4, and it becomes a 2. I can't do anything with the 3, so I'm going to leave it. And now I still need to isolate x, so I need to add 4 to both sides. So add 4 here and here. I can't add it to the 2, so it's just going to stay as 4 plus or minus 2 square root 3.
Wait, so 4 would go before it?
Yes. So generally they'll put the number in front and then the radical behind the plus minus. Now if you put the 4 behind it, that's fine, but this is generally how you're going to see answers like this written.
Oh, so if we put on the test, like,
All right, so for number 4, nice and simple here. I'm gonna rewrite it. To solve this, I just square root both sides, and I get x equals plus and minus 5. No negative numbers, no i's, just the plain old square root of 5. Underneath there. So let me rewrite it. So I get x squared equals 48. I need to square root both sides. So at this point I get x equals plus and minus square root of 48. However, 48 can be broken down. Doesn't matter how you break it down, you just need to get as much of the perfect square out, or all the perfect squares out as you can. I'm gonna factor it into 16 times 3. If you break it down into 6 times 8, you gotta keep going. But by my choosing 16 and 3, it's gonna get to my answer a lot quicker. The square root of 16 is 4, and there are no more perfect squares in the 3, so it stays. Here we go, number 6. So if you opened up the file earlier, I left off number 6. So here is number 6. If you open it up in class, it'll be fine. So here's my problem. Again, I'm going to square root both sides. And then I get x equals plus and minus the square root of negative 100. I need to break that 100 down. I'm going to make it negative 1. And then I know that 100, it's a perfect square. So out of that, I'm going to get plus and minus 10i. Because the square root of negative 1 is I, and the square root of 100 is 10. And then for number 7, again, I'm going to square root both sides. So let me rewrite it. X plus 4, or 4x plus 1 squared equals 20. I'm going to square root the left side, square root the right side. Square rooting that expression, that squared, cancels it away, and the 4x plus 1 comes out. I can factor the 20 into 4 times 5. If you do 2 times 10, you got to keep breaking it. So then I get 4x plus 1 equals plus and minus 2 radical 5. And now I'll begin isolating x by subtracting the 1. I'm going to put it in the front. And then divide by 4. So x equals negative 1 plus or minus 2 square root 5 over 4. Now, maybe in the answers when you check things like this, they might break it apart, and then they might even make this 1/2, or put it like that. So they may pull it apart. I can't simplify both of them. See how when I pulled it apart, really the only one I could have simplified is the 1/2, but the 1/4 stays there. So you can leave it like this, but if that 4 went into both, I would get rid of that 4 or simplify it. And then one more example. Now, if you opened, oops, did it get out of order? Again, I am going to rewrite it. So negative 2x plus 5 squared equals negative 8. To solve this, again, I square root both sides. The negative 2x plus 5 comes out of the radical. I could break my 8 into a negative 1 times 4 times 2. And then I can square root the negative 1, becomes I. I can square root the 4, it becomes 2, and the radical 2 stays underneath. So now I have negative 2x plus 5 equals plus and minus 2I square root 2. And now I begin isolating x. So I'll subtract 5. 2x equals negative 5 plus or minus 2I square root 2, and then divide by negative 2. And x equals negative 5 plus or minus 2I square root 2 over negative 2. Now, notice you have a negative in the top and the bottom. I could actually simplify that if I wanted to and make it positive 5 plus or minus 2I radical 2 over 2. So notice the plus minus, it flips 1 and then it ends up being a plus minus anyways. Yes?
What are the solutions for this?
Homework is page 124, and it's 13 through 29 odd. Remember, you have the new method for checking your answers. It is in that one file, the entire book. And if you find you have questions, have them ready for when you come in the next morning. Or if you're doing it and you want an answer the night before, you can always screenshot the problem and email me, and I'll try and get back to you before class. So that is solving by factoring and solving by using the square root method.